Hi, this is your second angled force problem. So in this particular case, we have a 20 kilogram box that's being pulled along at a 20-degree angle with a 75 Newton force. And now the coefficient of friction between the surface and the box is 0.25. So I'm asking, what is the acceleration of the box? So just like before, we're going to draw a free body diagram of the box. They told us that it's being pulled along at a 20-degree angle, and that's our applied force. And there's a normal force going up that's being provided by the table or surface, whatever it's resting on. And we have the force of gravity going down on it. We also have friction. I know there's friction because it's they give us a coefficient of friction. So they're asking us, what is the acceleration of the box? So that means, again, I only have one equation really to solve for acceleration that deals with forces. Now I'm going to put that up here in the top right, and that's sum of the forces is equal to ma. So the sum of the forces horizontally, because that's the only direction it can really accelerate. It can accelerate up at an angle of 20 degrees. It can't accelerate vertically, so the only real way it can accelerate is horizontally. So that means you got to look at my horizontal forces. So I do have my force of friction, but I also have the horizontal applied force. I have the component of the horizontal applied force. Okay, so there's my right angle. And here's also my FAY. I'll just put that down there. So now my sum of the forces. So I look at the forces acting horizontally, since that's going to be the direction of the acceleration. I can even write that down right there. The applied force horizontally is going in the same direction as the acceleration, so I'll make that positive. And the force of friction is going in the opposite direction, so I'll make that minus FF, and that's going to be equal to my MA. So my FAX, I see that's what I have to solve for to get my acceleration. I also got to solve for FF. Okay, but let's first start off with FAX. So FAX, looking at my free body diagram, it's adjacent to the angle. I know the hypotenuse, FA, is 75 newtons. So I'm going to use cosine. So FAX is equal to cosine of the angle, which is 20 degrees, times my applied force, which is 75 newtons. And so FAX ends up being 70 and a half newtons. Alright, so I can go and plug that in over here. That was pretty simple to do. Minus the frictional force. Now for frictional force, that's equal to mu times the normal force. I mean, again, I'm solving for frictional force. It is accelerating, so nothing's really equal to each other in this case, at least horizontally. So I can't really come up with a relationship like that. So I have to solve for frictional force using mu and normal force. So mu, they gave me to be 1.25. Normal force, I don't know, but I don't have an equation for normal force, but I can look at the other forces vertically, and I can use Newton's first and second law and say that the sum of the vertical forces is equal to zero because it's not accelerating vertically. So those forces, the upward forces, are balanced out by the downward forces. So let's see. So sum of the forces is equal to vertically. I have normal force going up. I also have the FAY going up. So I'm going to add those two together since they're going in the same direction. And I'm going to subtract the FG, and that's because it's going the opposite direction. And the sum of those is all equal to zero. So let's go and plug in what I know. And fortunately, or whatever, the normal force is my unknown first. FAY is my second unknown. Let's see if we can sneak in room somewhere. Let's do it down here. So let's solve for FAY down here. And FAY is opposite of my angle that I know, and I still know the hypotenuse, so opposite and hypotenuse, that's sine. So it's going to be sine of 20 degrees times 75 newtons. So there's my FAY, and the math I already did ahead of time. That's going to be 25.7 newtons. I can go and plug in 25.7 newtons there, minus F of G, which I actually have not solved for yet. So let me go and do that down here. That's pretty simple. That's just weight, which is mg. M is 20 kilograms. Gravity is 9.81 meters per second squared. And so my weight ends up being 196.2 newtons. So there's my weight. So minus the weight, 196.2 newtons. And all that's equal to 0. So to get Fn by itself, I'm going to add both sides by 196.2 newtons, subtract both sides by 25.7 newtons, and for normal force, I end up getting 170.5 newtons. Okay, so there's my normal force. Alright, so normal force I'm going to plug in to my frictional force equation, and I got 170.5 newtons. Make that decimal a little bigger. And so my frictional force ends up being 42.63, I'll just say 42.6 newtons. So there's my frictional force, and now I can go and plug that in up here into my very original equation. The sum of the forces, Newton's second law, minus 42.6 newtons, and that's equal to m. The mass was 20 kilograms times unknown a. So now I just do the subtraction, and then to get a by itself, I divide both sides by 20, and I get 1.40 meters per second squared. Okay, so again, I can do a quick recap here. So I always draw my free body diagram first. I'm solving for acceleration, so there's only one equation I know to solve for that. So I wrote that down just so I know what I need to solve for. It is accelerating horizontally, so I can look at the horizontal forces. So I saw my FAX I had to solve for, which I did here just by using trigonometry. And then I saw I need to solve for FF, frictional force, which the only way I can do it is using this, because there's no frictional force is not equal to anything else in this problem because it's accelerating. So I did that there. I saw I needed to solve for normal force, which I did right here, and then I plugged it back into here to get my frictional force, which I plugged into my original equation to get my acceleration 1.4. So that is your second angled force example problem.